How's it going, ladies and gentlemen? Mr. Donahue here once again. This time we're going to take a look at 4.5 and 6 problems, molarity and stoichiometry and titration problems. So let's start with number 23. What is molarity? This is a low-level question. You need to know this. Molarity, which is abbreviated with a capital M, is equal to the moles of the solute, so the stuff that's being dissolved, over the liters of solution. So remember, the solution is the mixture of the solute and the solvent. So that's the mixture. And then the solute is the stuff being dissolved, right? So that's what gets dissolved. And this is going to be used whenever we're doing like solutions, because we can measure out a volume of solution pretty easily using graduated cylinder, so we can know that. And if we're doing that, we want to know how much of our solute, because that's usually what we're interested in, is dissolved in that much solution. So molarity will be our go-to unit for concentration. 24. How would you make 1 liter of 0.2 molar K2SO4 solution? You have a bottle of K2SO4, which is solid, and a balance, and a graduated cylinder, and a gallon of distilled water. Well, first thing that you need to do, if you want to end up with 1 liter of 0.2 molar K2SO4, what you need to figure out is, well, all right, I'm measuring out a solid. For the balance, I'm going to have to get grams, so then I can figure out moles. So step 1 is going to be determine the number of moles needed. So how many moles of that stuff do you need? Second step is go, all right, well, how many grams is that? Convert that to grams. Then next, you're going to dissolve the solute, the grams of the stuff, in water until you have your desired volume. And it's important that you do it in this order. You're going to take a beaker and you're going to add your stuff to it, and then you're going to pour in the water. And the reason that you're going to do it in that order is because that volume depends on what the volume of the water is and the solute that you're adding to it. The solute takes up some space. So just taking however many grams you need of K2SO4 and dissolving it in 1 liter. So if you had, your grams plus 1 liter of H2O, you're going to get, maybe more than 1 liter of H2O. So you need to do it in that order. You need to add water to your grams so you get your final volume. So let's do the math for this one. We know that's our game plan. What is our math going to look like for figuring that out? Well, first, how do you figure out the number of moles? You got to look at the molarity, and you got to know that molarity is moles per liter. So I go, all right, well, if I want to figure out moles, I'm going to have to rearrange that. So I get molarity times liters equals my moles. So now let me plug that in. The molarity that I want is 0.200 molar times 1 liter, because I want 1 liter, right? It says make 1 liter. So I get 0.200 moles of K2SO4. So now next step is, how do I get grams? Well, first I need to get the gram formula mass. So let me do that math for me. I got to look up the K, and there's 2 of them, so I'm going to have to do 2 times the mass of potassium, which is at 39.10. And then I'm going to have to add that to the mass of 1 sulfur, which I look up sulfur's mass. It's 32.06. And then I add that to the mass of 4 oxygens, because it's SO4, so it's going to be 4 times the mass of oxygen, 16.00. That is for oxygen, and I end up with a gram formula mass of 126.26 grams per mole. So now I got to do one more step and go, all right, well, that's how many grams per mole it is. This is how many moles I need, so I got to times that by the number of moles that I need, 0.200, and I end up with 25.25 or 25.3 grams of K2SO4. So now the last step is I get a beaker or a graduated cylinder, or ideally it'd be a volumetric flask that's marked to 1 liter, and you're going to add your salt. So first, add your salt into the solution, or into the beaker, and then add water until you've reached the 1 liter. So then you add water to it till it fills up to 1 liter, and then you're done. That's how you do it. All right, 25. How many milliliters of 0.350 sodium hydroxide would you need to neutralize 12.5 milliliters of HCl? So we're trying to get moles to equal moles with neutralization. We want moles of the acid to equal the moles of the base. And if they're giving me concentrations and volumes, I gotta go, all right, well, what links those? Well, molarity links those. I know molarity is moles per liter. So if I wanted to rearrange that to solve for moles, I know that moles is going to be equal to the molarity times the liters. So this right here, I can change it. If moles of the acid is equal to the molarity of the acid times the liters of the acid, I can do molarity of the acid times the liters of the acid equals, well, the base is going to be the same deal, right? Molarity of the base times the liters of the base is going to give me moles of base. So I'm trying to get those to equal each other. So let me plug in what I know. Well, I got 0.350 molar of NaOH. So that is going to be my base. So it's going to be that 0.350 molar times the liters of the base, which is what we're trying to find out, has to equal the molarity of the acid, which is this 0.125 molar. So 0.125 molar times the liters of the acid. Here they give me milliliters. And because this is really a proportion, I have this equal sign on both, and I have the left side and the right side. I can use milliliters, but then when I solve for my volume of the base, it's also going to be in milliliters. So I'm going to leave that as 12.5 milliliters. And instead of just saying liters of base, I'm just going to say the volume of the base. I'm going to be more generic for that. So now let me rearrange this. And I'm going to get the volume of the base equals 0.125 molar times 12.5 milliliters divided by 0.350 molar. And here, look at the units. Molar cancels out. So my volume is going to be in milliliters. When I plug and chug that, the answer that I get is 4.46 milliliters. So that'll be how many milliliters of the base I need to neutralize that much of that acid. 26. How many moles of sodium hydroxide are in 45 milliliters of 0.25 molar solution of sodium hydroxide? So again, I'm going to go, well, I know my molarity is equal to my moles per liter. And if I'm trying to solve for moles, rearrange that. I get moles equals the molarities times the liters. So now I'm going to plug and chug. I go, all right, well, I got 0.250 molar times the liters. Here they give me milliliters, though. So I got to quick divide that by 1,000 milliliters per liter so that I end up with liters, and I get 0.04500 liters. And when I plug and chug that, I get an answer of 0.0113 moles of NaOH, sodium hydroxide. All right, 27. What are the concentrations in molarity of Mg plus ion and the acetate ion afforded by dissolving 0.500 moles of magnesium acetate in water and diluting to a final volume of 0.240 molar? So first step, let's figure out what is the molarity of the Mg, the magnesium acetate. Because what's going to happen when this dissolves? Well, let's think about it. I'm going to start with my magnesium acetate, which is 1 magnesium ion and 2 acetate ions. And it's going to dissociate when it dissolves. It's going to break up into an Mg plus 2 ion and 2, because there's 2 acetate ions, so 2 acetate ions separately. So if I want to figure out what are the concentrations of these guys, I need to know, well, what is the concentration of what I started with? So what is the molarity of that? Well, let's figure it out. I know molarity equals moles per liter, and they tell me that I had 0.500 moles and over 240 milliliters, which is going to be equal to 0.240 liters. So 0.50 divided by 0.240, and I'm going to get 2.08 molar as my concentration. So I'm not done, because that's the concentration of Mg C2H3O2, my magnesium acetate. So second step, I'm going to have to look at the concentrations of each ion. So concentrations of each ion. Well, it's a 1-to-1 ratio between the magnesium acetate and the magnesium ion. So Mg plus 2 is going to be the same concentration. It's going to be that 2.08 molar. But it's a 1 to 2 ratio between the magnesium acetate and the acetate ion. So if I want to know the acetate ion, it's really going to be 2 times whatever the concentration of this was. So it's going to be 2 times 2.08 molar, and I'm going to get 4.16 molar. So concentration for the acetate is the 4.16 molar, and the concentration for the magnesium is 2.08. All right, 28. What are the concentrations in molarity of copper plus 2 ion and chloride afforded by dissolving 0.850 moles of copper chloride in water and diluting it to that many milliliters? So it's like the same problem before, but it's different numbers. So first step, what is the molarity of the copper to chloride? Well, again, molarity equals moles per liter. So I take the moles, which they tell me right off the bat, which is nice. So 0.850 moles divided by this milliliters. I got to convert it to liters. I'm going to end up with 1.045 liters. So I'm going to use that, 1.045 liters, and I get a molarity of 0.814 molar. So now the second step is, all right, well, let's think about what's going on. I start with copper chloride, and it's going to break up into the copper plus 2 ion and 2 chloride ions because it's Cl2. They're going to split up and be 2 independent chloride ions. So now that's going to be the relationship for the concentration. I found copper chloride as a whole to be 0.814 molar. And if I take a look, it's a 1-to-1 ratio between copper chloride and copper. So the copper ion is also going to be 0.814 molar. But this chloride ion is going to be twice as much. So it's really going to be 0.814 molar times 2, which when I do that math, I get 1.628 molar. And there you go. Those are your concentrations for those guys. All right, 29. How many grams? Oh, interesting. This time we're stepping it up a notch. They want grams. How many grams of sodium hydroxide are dissolved in 423 milliliters of 0.250 molar solution of sodium hydroxide? All right, well, let's figure this out. If I want to get grams, I'm going to have to first get moles. So I got to get moles from using the molarity equation, and then from the moles, I can go from moles to grams using the GFM, the gram formula mass. So first step, figure out the moles. I know it's 0.250 molar has to equal the number of moles over liters of solution. So I got to convert this milliliters to liters. So I divide by 1,000, I get 0.423 liters, which means when I do the math, I rearrange, I get number of moles. It's going to equal 0.250 molar times 0.423 liters. So when I plug and chug and do that math, I'm going to get some number, right? I get 0.10575 moles. So now all I got to do is convert my moles into my grams. So I got to go, all right, well, 0.10575 times my gram formula mass of NaOH. So I got to look up, well, what is NA's atomic mass? And it's going to be 22.99 plus, all right, so NaOH is my sodium hydroxide, so the Na is 22.99, the oxygen is 16.00, and the hydrogen is 1.01. So when I add all that together, what I get is 40.00. So it's really this number times 40. When I do that, I get 4.23 grams as my final answer. 30. How many grams of silver bromide, AgBr, is formed when 25 milliliters of 0.176 molar solution of silver nitrate, AgNO3, is reacted with excess hydrobromic acid? All right, so this is kind of obnoxious, and I would start, all right, here they're describing a reaction. Why don't I write out the equation for that reaction? So we're talking about forming AgBr, so I know that AgBr is a product. And it says when that much of silver nitrate is reacted with, so silver nitrate is my reactant, and it's reacted with excess hydrobromic acid, which is HBr, so it's going to be plus HBr. And they go, all right, well, they didn't tell me about the other product, but I got to figure it out, right? If Ag ends up with Br, what's left is H and NO3, so it's going to be HNO3. And then I'm going to check to see if everything's balanced, which convenient for this problem, it is. Right, 1Ag, 1Ag, 1N, 1N, 3 O's, 3 O's, 1H, 1H, and 1Br, and 1Br. All right, cool. So I know that everything's going to be a 1-to-1 ratio. So how much AgBr is formed when 25 milliliters of 0.176 molar solution of silver nitrate. So we're talking about these two things is reacted with excess hydrobromic acid. So the excess is telling me that AgNO3 is my limiting reactant. I don't have to worry about how much HBr there is. There's extra. So I'm going to have to figure out, well, how many moles of AgNO3 do I have so I can figure out the moles of AgBr. So in order to do that, well, to get moles from this concentration, I know that moles equals a molarity times the liters. So when I plug that in, I get molarity of 0.176 times 0.0250 liters because I had to convert this 25 milliliters to liters. And when I do that, I get an answer of 0.0044 moles. So now I got to go, all right, well, what's my AgNO3 to AgBr molar ratio? Well, it's 1-to-1. So if I had 0.0044 moles of AgNO3, then how much AgBr do I get? I get 0.0044 moles of AgBr. And I'd be done if it wasn't for the fact that they asked for how many grams. So I got to go, all right, well, I need to know the formula mass of AgBr. So I look up what's the mass of Ag. It's 107.87. And what is the mass of bromine, Br? And I look that up, and it's 79.90. So when I add them together, I get 187.77 grams per mole. And if I have that many moles, what I got to do is I got to multiply 0.0044 moles times 187.77 grams per mole. Moles cancels out, and I'm left with just grams, and my final answer is going to be 0.826 grams. All right, one more if I'm not mistaken for this section, and then we're done. 31. What volume of 0.0500 molar nitric acid can be neutralized by 225 milliliters of 0.230 molar sodium hydroxide? So it's saying we got nitric acid, HNO3, reacting with sodium hydroxide, which is going to give me water, and a salt. And the salt's going to be the sodium with the nitrate, so sodium nitrate. Right? So what volume of 0.050 molar nitric acid? Oh, hey, I know that this is one of those molarity of my acid times the volume of my acid has to equal the molarity of my base times the volume of my base kind of problems. So let me just go, well, what are they asking me for? They want the volume of the acid. So I'm solving for Va. So why don't I just get Va by itself first? And there we go. I rearrange that equation. And now all I got to do is plug and chug. The molarity of the base, they said, was 0.230 molar, and they said the volume was 225 milliliters. And the molarity of the acid was 0.0500 molar. The molar units cancels out. I'm going to be left with my answer in milliliters. So when I plug and chug that, I get 1040 milliliters. What I really get is like 1035, but because this has 3 sig figs, 3 sig figs, 3 sig figs. My answer has to have 3 sig figs. So I go 1, 2, 3. I look over, that's a 5. So I'm going to have to round that up to 4. So I get, bam, 1040 milliliters. All right, I hope you found that helpful. I'll see you in class.